The Basque blood mystery, hidden in the cave. In 2015, a team of scientists extracted ancient DNA from skeletal remains discovered deep inside a cave in northern Spain. The cave was called El Portalón, and the bones had been lying there for somewhere between 3,500 and 5,500 years. When the genetic results came back, they didn't just answer one question. They answered a question that had been circling the edges of science, mythology, and pure human curiosity for over a century. Who are the Basque people? And why is their blood unlike anything else on Earth? If you have never heard of the Basques, here is the short version. They live in a mountainous region straddling the border between northern Spain and southwestern France, in the foothills and valleys of the Pyrenees. There are roughly 3 million of them. They have their own flag, their own cuisine, their own folk traditions, and their own sports. And they have two things that have puzzled scientists since the modern era of genetics began. The first is their language. Euskara, the Basque language, is what linguists call a language isolate. It has no known relatives anywhere on Earth. It is not related to Spanish, French, Latin, Greek, or any other Indo-European language. It is not related to Arabic, to Berber, or to any Semitic language family. It is not related to any language currently spoken on this planet. When you try to trace its origins through the standard tools of comparative linguistics, you hit a wall. The language simply appears, fully formed, with no traceable family connections. The second is their blood. Specifically, the extraordinarily high frequency of Rh-negative blood type in the Basque population. Globally, roughly 15% of people carry Rh-negative blood. Among the Basques, that number reaches somewhere between 30 and 35%, more than double the global average and higher than any other population on Earth. This combination, an untraceable language and an anomalous blood type, generated theories that ranged from the scholarly to the spectacular. The Basques had been proposed as descendants of the lost civilization of Atlantis, as survivors of a pre-flood global culture, and, in the more colourful corners of the internet, as partial descendants of extraterrestrial visitors, with the Rh-negative blood as genetic evidence of non-human ancestry. The cave of El Portalón was about to put most of those theories to rest. The Atapuerca mountain range in northern Spain is one of the most important archaeological sites in the world. Excavations in its various cave systems have produced some of the oldest hominin remains ever found in Europe. Bones of human ancestors stretching back nearly 1 million years. The site is a UNESCO World Heritage location, and it has been under continuous excavation by teams from Spanish universities since the 1970s. El Portalón is one of the cave entrances within the Atapuerca complex. Unlike some of the deeper cave systems at the site, El Portalón served as a habitation space, a place where people actually lived, cooked, slept, and buried their dead across thousands of years. The archaeological layers inside it represent an almost unbroken record of human occupation from the Neolithic period through the early Middle Ages. When archaeologists working the site began finding skeletal remains in the cave's Neolithic layers, they recognized immediately that these were not incidental deaths. The burials showed intentionality. Bodies had been placed, arranged, and in some cases accompanied by objects. Pottery fragments, animal bones, stone tools, ornaments made from shell and animal teeth. This was a community that took its dead seriously and placed them in a space that clearly held ritual significance. 8 individuals were recovered from the relevant stratigraphic layers, dating to between approximately 3,500 and 5,500 years before the present. These are the window into the Neolithic and early Chalcolithic periods, the era when farming had recently arrived in the Iberian Peninsula and was transforming everything about how people in the region lived. The condition of the remains was exceptional. Cold, dry cave. Environments can preserve bone with remarkable fidelity. And the petrous bone, the dense pyramid-shaped bone of the inner ear, is the hardest bone in the human body. It is also the structure that best preserves ancient DNA, because its density slows the chemical degradation that destroys genetic material in softer tissues and lighter bones. Researchers extracted samples from the petrous bones of the Portalón individuals and sent them to ancient DNA laboratories for sequencing. The results came back in 2015 and were published in the journal Current Biology. They would reshape the entire academic conversation about Basque origins. The DNA extracted from the Portalón cave burials told a clear and specific story. These people were not hunter-gatherers. They were farmers, members of the Neolithic agricultural revolution that had spread across Europe beginning around 9,000 years ago, originating in the ancient Near East, in the region of modern Turkey and the Levant. Their genetic profiles matched what scientists had by 2015 already established as the signature of early European farmers. Ancestry that traced back to Anatolian agricultural populations, mixed to varying degrees with the ancestry of the hunter-gatherers who had been living in Europe before the farmers arrived. This was not a surprise in itself. By the mid-2000s, ancient DNA research had established fairly clearly that Neolithic Europe was populated by two main genetic streams: the ancient hunter-gatherers who had lived in Europe since the Ice Age, and the incoming farmers from Anatolia whose descendants spread across the continent over several thousand years, largely replacing the hunter-gatherer populations in most regions. What was surprising, genuinely scientifically surprising, was what happened when the researchers compared the Portalón ancient DNA to modern population databases. Of all the modern European populations they tested, the ancient Portalón individuals were most genetically similar to one group: present-day Basques. Not to modern Spaniards, despite the Basques living in Spain. Not to modern French people, despite the Basques straddling the French border. Not to any of the other populations of the Iberian Peninsula. The closest genetic match to these 5,000-year-old cave inhabitants was the living Basque population of the 21st century. The implication was significant. The Basques were not a mysterious people who had arrived from somewhere unknown. They were the people who had always been there, the descendants of the earliest farmers to enter the Iberian Peninsula, who had maintained their genetic continuity across 5 millennia through a combination of geographic isolation and cultural resistance to outside influence. The mystery was not where they came from. The mystery was how they had stayed so unchanged while everything around them transformed. To understand why the Basque genetic profile remained so stable across 5,000 years, you need to understand the geography of the Pyrenees and what the rest of Europe was going through during that period. Around 5,000 years ago, something massive happened to the genetics of Europe. A new population began moving westward from the Eurasian steppe, the vast grasslands stretching across what is now Russia and Ukraine. These people, associated with what archaeologists call the Yamnaya culture, were herders and warriors who moved on horses and in wheeled vehicles. They carried a genetic profile dramatically different from both the ancient hunter-gatherers and the Neolithic farmers already living in Europe. The genetic impact of the Yamnaya expansion was enormous. In most parts of Europe, ancient DNA studies show that steppe ancestry arrived rapidly and in large proportions. In some regions, replacing 50 to 90% of the existing genetic pool within just a few generations. Whatever combination of migration, assimilation, and conflict drove this process, its genetic consequences were among the most dramatic in the entire human record. In most of Europe, the Basque country sits tucked behind the western end of the Pyrenees, a natural wall of mountains reaching over 3,000 meters in height, running for over 400 kilometers from the Atlantic coast to the Mediterranean. The specific valleys where Basque communities were concentrated were and remain some of the most geographically isolated inhabited areas in Western Europe. Access from the north required crossing high mountain passes that were frequently closed by snow. Access from the south required navigating the rugged terrain of the Cantabrian coastline. Ancient DNA studies of Basque populations confirm what the geography suggests. The steppe ancestry that flooded the rest of Europe barely reached the Basque region. The genetic signal that completely transformed populations from Ireland to Poland, from Scandinavia to Greece, appears in the Basque DNA record at dramatically lower levels than anywhere else in Western Europe. The mountains were not just a physical barrier, they were a genetic one. And the people living behind them stayed, generation after generation, generation after generation, who they had always been. Let's address the theories directly, because for a long time, before the ancient DNA evidence came in, the Rh-negative blood type was the centerpiece of a remarkably persistent set of alternative explanations for Basque origins. The argument, in its various forms, went something like this. Rh-negative blood is rare globally. The Basques have far more of it than anyone else. The Rh factor itself, the protein on the surface of red blood cells that determines positive or negative status, relates to a specific gene called the Rhce gene. People who are Rh negative have a version of this gene that lacks what is called the Rhd antigen. When an Rh negative mother carries an Rh positive fetus, her immune system can recognize the fetal blood as foreign and produce antibodies against it, a condition called hemolytic disease of the newborn, which can be fatal. This biological conflict between mother and child seemed, to some writers, like evidence of something fundamentally alien about the Rh-negative blood type, something that did not belong in the normal human biological framework. From there, the leap to extraterrestrial origins was made by some writers with remarkable confidence. The scientific explanation is considerably less dramatic, but considerably more interesting. Rh-negative blood is simply a genetic variant, a naturally occurring mutation in the Rhd gene that removes the D antigen from the surface of red blood cells. It is not harmful. It is not mysterious. It has no known impact on the health or capabilities of the person who carries it. It is one of thousands of genetic variants that exist in human populations. The high frequency of Rh-negative blood in the Basque population is explained by a well-understood population genetics phenomenon called the founder effect. When a small, isolated population descends from a limited number of founding individuals, genetic variants that happen to be present in those founders, even rare ones, can become common simply through random genetic drift over many generations. If the founding Neolithic population that settled in the Pyrenees happened to carry a relatively higher than average frequency of the Rh-negative variant, and if that population remained isolated from genetic exchange with outside groups for thousands of years, the frequency of that variant could rise substantially without any unusual mechanism being required. The cave of El Portalón confirmed the isolation. The genetics explained the blood. The extraterrestrial hypothesis was not needed. Of the two great Basque mysteries, the blood and the language is, in some ways, the more remarkable one. Euskara is spoken today by roughly 750,000 people, primarily in the Basque autonomous community of Spain and the adjacent region of Navarre, with smaller communities in the French Basque country. It is actively taught in schools, used in media, and protected by regional government policy. Basque children grow up bilingual in Euskara and either Spanish or French, depending on which side of the border they live on. But Euskara's survival into the modern era is, historically speaking, a near miracle. It has no known linguistic relatives anywhere on Earth. Not in Europe, not in Africa, not in Asia, not in the Americas. Linguists classify it as a language isolate, meaning that its entire family tree consists of a single branch with no connections to any other branch anywhere in the tree of human language. How did this happen? The ancient DNA evidence from El Portalón provides the key piece of the puzzle. If the Basques are the genetic descendants of the very earliest farmers to enter the Iberian Peninsula, people who arrived from Anatolia around 7,000 to 8,000 years ago, then Euskara may be a surviving relic of the language those farmers spoke. Before the Indo-European language family spread across Europe, carried by the steppe migrations of 5,000 years ago, and later by the expansion of Latin through the Roman Empire, Europe was linguistically much more diverse than it is today. Many languages that predated the Indo-European expansion were simply wiped out as their speakers were absorbed into Indo-European speaking populations. In the Basque region, the geographic isolation that preserved the genetics also preserved the language. The steppe migrants who replaced most of Western Europe's population, and whose descendants eventually spoke the ancestors of Latin, Greek, Celtic and Germanic languages, never fully penetrated the Pyrenean mountains. And so the language spoken by the people who had always lived there survived, intact, while every neighbouring language was replaced. Researchers examining cave sites in the Basque region have found symbols and markings on cave walls that some scholars believe may represent a very early precursor writing system. Whether these connect directly to the Euskara linguistic tradition is debated. But the physical presence of these markings in the same caves where Basque ancestors lived and buried their dead is a powerful reminder that this cultural continuity stretches back further than any written record can reach. The El Portalón cave was not just a burial site. The archaeological evidence tells the story of a living community that used this space over many generations for purposes that went far beyond simple habitation. The deepest and oldest layers of occupation show the characteristic debris of daily Neolithic life. Animal bones from domesticated cattle, sheep, and pigs indicating a farming rather than purely hunting economy. Carbonized seeds from cereal grains, including wheat and barley. Fragments of simple pottery used for cooking and storage. And the remains of fires that burned in roughly the same locations generation after generation, suggesting the cave had stable, organised use over long periods. The burial practices reveal something about how these people understood the relationship between the living and the dead. Several of the recovered individuals were interred in what is called the fetal position, knees drawn up, body curled inward, mimicking the posture of an unborn child. This burial style is documented across a wide range of Neolithic cultures and is generally interpreted as reflecting a belief in rebirth or cyclical continuation of life after death. The body returned to the position of its beginning, ready to be born again into whatever came next. Alongside the bodies, archaeologists found grave goods that suggest these were not anonymous burials of the poor or insignificant. Shell ornaments, polished stone beads, carved animal teeth used as pendants, objects that required effort and skill to produce, and that someone placed deliberately with the dead. These were people who were known, mourned, and honoured. Chemical analysis of the dental remains, specifically the tartar and microwear patterns on the teeth of the El Portalón individuals, provides a direct window into what they ate. The results show a mixed diet: cereals, dairy products, and animal protein. The presence of dairy residue in the dental calculus of people who lived 5,000 years ago is consistent with what genetics has independently revealed: that Neolithic European farmers developed lactase persistence, the ability to digest milk into adulthood, a genetic adaptation that spread rapidly with the farming lifestyle. And DNA extracted from the dental pulp contained not just the human genome, but traces of plant compounds consistent with medicinal herb use, suggesting these people had already developed a systematic relationship with plants for health purposes that would eventually, thousands of years later, become the foundation of herbal medicine traditions that persist in Basque folk culture into the modern era. Rome conquered almost everything it touched. Between roughly 200 BC and 400 AD, the Roman Empire extended its political and military control across most of Western Europe, North Africa, and the Near East. Wherever Rome went, it brought Latin, and Latin, over centuries, transformed the languages of the conquered peoples. The ancestors of modern Spanish, French, Portuguese, Italian, and Romanian were all Latin, imposed on populations whose original languages were gradually forgotten. In the Iberian Peninsula, Rome's conquest was thorough. The native Iberian and Celtiberian languages that had been spoken across most of modern Spain disappeared within a few centuries of Roman arrival, replaced by Latin. The genetic impact of the Roman presence, the soldiers, administrators, merchants, and enslaved people who moved through the peninsula, is detectable in modern Spanish and Portuguese DNA. In the Basque country, something different happened. Roman sources from the period document attempts to extend imperial control into the Pyrenean valleys occupied by the Basques. What the archaeological record shows is that these attempts were limited in their effectiveness. The mountainous terrain that had protected Basque genetic and linguistic isolation for thousands of years proved equally effective as military cover. Hit-and-run tactics conducted from elevated terrain by people who knew every valley and ridge were extremely difficult to counter with the Roman military's preferred mode of organized, formation-based warfare. The genetic evidence is unambiguous. Ancient DNA studies comparing Basque populations before and after the Roman period show minimal change in the Basque genetic profile attributable to Roman admixture. The signal that would indicate substantial intermarriage with Roman-era populations, elevated levels of Near Eastern and North African ancestry of the type introduced by the Roman military and administrative system elsewhere in Europe, is nearly absent from the Basque DNA record. A skeleton recovered from a cave site in the Basque region, dating to the period of Roman presence in Iberia, shows healed fractures consistent with repeated physical trauma, the kind of injury pattern associated with individuals who experienced regular physical confrontations over many years. It is one individual. It is one data point. But it is a data point that fits the historical record. The Basques fought and fought effectively, and the Romans ultimately found it more practical to establish a relationship of limited accommodation with the mountain communities than to attempt their complete subjugation. Euskara, the language, survived Latin. The genetics, the ancient farming profile from El Portalón, survived the Roman genetic flood. Both facts point to the same underlying reality. The Pyrenees created a space where ordinary historical forces did not reach with their full power. The story of the Basques does not end in the mountains. It extends in ways that most people have never heard across the Atlantic Ocean. Beginning in the 15th century, and possibly earlier, Basque fishermen and whalers became some of the most accomplished mariners in the North Atlantic. Their pursuit of cod and whale brought them regularly to the waters off Newfoundland, Labrador, and the coasts of what is now Atlantic Canada, decades before European colonial settlement of those regions became a sustained political project. Basque whale processing stations have been excavated at Red Bay in Labrador, dating to the 1500s, and represent some of the best preserved early European industrial sites in the Americas. The genetic impact of this maritime presence is detectable. Studies of DNA from indigenous communities in Newfoundland and Labrador have identified small but statistically significant traces of Basque genetic ancestry that are most consistent with the period of Basque fishing activity in those waters, suggesting that contact between Basque mariners and indigenous populations was close enough, over a long enough period, to leave a measurable biological trace. This gives the Basque genetic story a genuinely global dimension. A population that preserved its ancient farming DNA by retreating into the mountains of the Pyrenees, that resisted Roman conquest and every subsequent wave of European migration and conquest, also sent its sailors to the far edge of the North Atlantic centuries before Columbus made his famous voyage. The same people, the same genetic line that traces back to the cave of El Portalón and the Neolithic farmers of 5,000 years ago. The Rh negative blood type that generated so many colourful theories about extraterrestrial origins has, in the modern world, a genuinely important medical significance. Rh negative blood is universally compatible for transfusion with Rh negative recipients and can be used in emergency situations before blood typing is completed. The Basque population's high frequency of Rh negative blood has made Basque communities historically significant donor populations for medical blood banks in Spain and France. The ancient genetic quirk preserved by thousands of years of isolation turns out to have a practical value in the modern world that nobody in a Pyrenean cave 5,000 years ago could have imagined. And for the growing number of people who have taken commercial DNA tests in the last decade, the Basque question has become personal. The ancestry databases maintained by companies like 23 and Me and Ancestry DNA now contain enough Basque reference samples that some users, particularly those with ancestry from the Atlantic coastal regions of Western Europe, are discovering Basque genetic components in their own results that they had no previous reason to suspect. The ancient DNA from El Portalón, combined with modern population genetics, has made it possible to trace a biological thread that connects the present to a cave in the Spanish mountains, and through that cave to the very first farmers who ever walked across the Pyrenees. Let's pull back and look at what the El Portalón discovery actually means in the context of everything we know about human prehistory in Europe. Europe, as a genetic entity, has been remade at least 3 times in the past 12,000 years. The first Europeans, in the sense of the first anatomically modern humans to inhabit the continent after the last ice age, were the Paleolithic hunter-gatherers. And they had arrived in Europe from Africa and the Near East tens of thousands of years earlier, adapted to cold climates and mobile hunting lifestyles, and produced the extraordinary cave paintings of Lascaux, Altamira, and the other great painted cave sites of France and Spain. Their genetic profile is distinct and well characterized by modern ancient DNA research. The second wave came with the Neolithic farmers, the agricultural communities whose ancestors had developed farming in Anatolia and the Fertile Crescent, and who spread westward across Europe, beginning around 9,000 years ago. In most of Europe, they replaced the hunter-gatherer population substantially, though never entirely. The El Portalón individuals belong to this second wave. They are these farmers. The third wave, the steppe pastoralists of the Yamnaya culture, arrived approximately 5,000 years ago and transformed the genetics of most of the continent so thoroughly that their ancestry now forms the largest single component of the European genetic profile in most regions. This wave brought the Indo-European languages that became Latin, Greek, Celtic, Germanic, Slavic, and Baltic. It brought new social structures, new technologies, and a new biological profile that spread with remarkable speed. The Basques, as the ancient DNA from El Portalón confirms, are the clearest surviving example of what Europeans looked like before that third wave arrived. They are not a genetic curiosity. They are a living archive. In their genomes, and in the children being born in Bilbao and San Sebastián and Pamplona today, lives a genetic inheritance that predates the arrival of the Indo-European world. A biological memory of a Europe that existed before Rome, before the migrations that built modern European nations, before the language families that connect nearly every other European tongue. The cave of El Portalón did not create a mystery. It solved one. For generations, people looked at the Basques, their strange language, their unusual blood, their fierce independence, and reached for supernatural explanations. Because the natural explanation seemed insufficient. How could a people be so different, so persistent, so unchanged in a world that changes everything? The answer was simply time, geography, and stubbornness. Time enough for 5,000 years to pass with the same DNA moving from parents to children in the same mountain valleys. Geography enough to keep the world's disruptions at arm's length. And a stubbornness, cultural, linguistic, biological, that refused generation after generation to be absorbed into the larger story. They are the last direct genetic representatives of Europe's first farmers. And they are still there, in the mountains, speaking a language that has no relatives, carrying blood that the world finds unusual, descendants of the people in that cave. The archive is still open,